Yeah, thanks so much for coming. So that's me. My name is Joe Winchester, and I work for a company called IBM, International Business Machines. And Louisa?
Yeah, I'm Louisa. So I have two hats. Open source chairperson for a project called Galasa, which we'll talk about, and also a product manager for, I work in kind of kicks and integration, so how do we get in and out of the Z box? So depending on how much you guys know about Z, will depend on how nerdy I can get.
Yeah, so it's awesome that you're here. We have a small audience. We're just 4 people in the room. So we have a set of charts. We have a kind of narrative that we thought would be interesting. But before we do that, I want to make sure you came into this room with some idea as to you were going to hear something or ask a question or leave behind some information in the room. So can I just have a quick... we're going to talk about the mainframe. Does the mainframe mean anything to anybody in this room? We've got a nod, we've got a nod, we've got something. Okay,
how much do you know about the mainframe?
A little bit
What's
of a wiggle. Okay.
You've heard of it?
Big scary box.
Big scary box.
Okay.
Okay, so let's go on.
Hang on, have we got an advance on the big scary box? Or is that the...
About the same? You're not
Yeah.
wrong, it is a big scary box, yeah.
It's a good place to start.
We're going to talk about that. So we were going to exact mainframe mythbusters. So what we're trying to do today is paint a picture of the mainframe or IBM Z hardware as it is and its relevance and why we're rocking up at a conference that seems to be the complete antithesis of IBM, right? And everything that IBM, you may or may not think IBM stood for. So we're going to do a bit of myth busting. But we can bust any other myths you want to, or you can challenge us and we can go, yeah, you're absolutely right. You know, that bit does suck and we haven't got around to it. The first one we're going to bust is that nobody uses the mainframe. A lot of people just think, oh, it's something dead. You know, I watched a movie about, the moon landings and they talked about mainframes and that was, the last time they were used was 1969, I think, was an Apollo 11. And they were used then. They didn't take one to the moon. It was used on the ground by JPL, Jet Propulsion Laboratory. Mainframes are proprietary. They most certainly were once upon a time. The IBM Z machine has a heritage that dates back to 1964 when the original operating system called S360 came out or something. And it's changed names and it's full of lots of 3-letter acronyms I won't bore you with. So yeah, once upon a time it was proprietary. That's not the case anymore. Another myth is that, well, I'll talk about it, is that mainframes run a language called COBOL, which they do, and they do it very well and very fast, so we'll talk about that, and that there is no intersection between mainframes and open source, and we're here to challenge that. Thank you for coming, Liz. Our numbers have gone up. Woohoo! Just for the record, we have one more in the room. So we're up to 5, we're in our quorum. And we've got a little bit of picture.
The big scary box, literally, as a picture.
Yeah, we had. So does that sound like a decent agenda? If there's anything that we don't cover, just fire and shoot. Louisa and I are most comfortable when we're just kind of like riffing with questions. So myth 1 that we're going to talk about is that nobody uses a mainframe anymore. Okay? And some of that's sort of true. If you Google for the word mainframe, you're probably going to come up with something like this. It's probably going to be a black and white picture of somebody. There might be some tapes running in the background, no reel-to-reel tapes. Probably some flashing lights.
Some green screens, probably.
Yeah, some green screens, which are actually black screens with green on them.
Yep.
But they have the word of green screens. Because as I said, the heritage of the IBM Z machine. And once upon a time, before personal computers were created, this basically was what computers were. These are the latest machines from IBM. And I'm not...
They were released like 3 months ago?
Sell you IBM. They come in 2 flavors. They come in this, which is kind of blue and orange flavor. But this one has got the word LinuxOn. I don't know if you can read at the back. So what we'll try and talk about today is that there's a chipset on the IBM Z machine. It's called a Telum 2 Telum processor. Anyway, it's also on other bits of IBM hardware. IBM makes it. It's on various storage devices called the DS8K and IBM Power and things like that. And it has its own architecture, so it can run all of the stuff that was written in 1964 unmodified, which is kind of cool, because there are a lot of people who've got software that they wrote, perhaps not that far back, but certainly in the 1970s. There's still a lot of software that's running, powering the world's economy. And it also runs Linux, what's called C Linux. And those can be co-located on the same machine. We'll talk about that. Or you can also, if you particularly want to, make an IBM salesperson's day very happy, you can buy a unit that is entirely customized to run Linux and entirely optimized to run Linux. It doesn't run any of the older software, what some people sometimes call legacy software. Is that cool? Any questions about that? So, you have a question? Hands up. Go for it, sir.
How big are they?
So I'm just going to repeat the question for the recording. How big are they? I love that question. They're about as big as a fridge freezer.
Well, so I went to the data center like a couple of weeks ago, and they're in the same as a rack of x86 servers. So they used to be like a crazy, unique size, and that used to be problematic because you'd have your own cooling rack and your own kind of space in the data center. Now it's the same. So, and you can buy them as racks that you can just
buy
put
them
in
as
well.
racks. So you can just buy them as a rack.
They don't always look like that. They normally look like that only if they have the door. But if you take off the door, they look like any other normal.
But then you need to buy
servers.
a separate power supply, plumb it into. This particular model is like completely glycogen cooled and everything, and it's all. And an interesting thing, this sounds like a mainframe infomercial, but I'll just carry on another thing like that.
Okay.
This has an uptime, a hardware uptime of 8 nines, so it's 99.999999, which I think is 3 milliseconds of unplanned downtime per year. And it's a bit like an octopus. So I'm just going to, I love that look, a bit like an octopus. Yeah. So octopuses are cephalopods. Wow, try saying that. Cephalopods? Anyway, they're actually independent organisms with completely separate genotypes that have kind of coalesced to create a thing that swims. So you can kill a part of an octopus. Please don't suggest it, because I'm vegetarian. But you can rip off a part of an octopus, and another octopus will bind on and adapt to be, depending on what that octopus is adapted for, the swimming piece or the other thing bit. So octopuses stay alive forever, because as one of them dies, as a new one comes along.
You haven't just joined an aquarium talk.
I'm sorry.
Good.
So with these, you can literally pull out a bit of hardware and put a new bit of hardware in, and it's very, very, very fault tolerant. And lots of banks run multiples of these in what's called active-active, so they'll run a data center, fiber optic to another one, 40 miles, I think, 60 kilometers is the maximum you can have. So if something catastrophic happens at one site, the other site is just on hot standby, and lots of cool things. Anyway.
I mean, we are at a finance conference, so it powers about 70% of the world's transactions, finance transactions. So think of any time that normally when I talk to my friends about the mainframe, I always say every time you tap your card, most of the time it will run through a mainframe at some stage. Insurance companies will use it, mortgage applications, anything that you can think of in terms of the finance.
Banking.
Banks.
You're a bank, you have a mainframe.
Yeah.
More than one of them.
As I say, up there it's about 29 billion annual ATM transactions. So we have in our testing facility ATMs that you can go and test, because it needs to be simultaneously updating so if we're all paying at the same time, it needs to be able to update the back end all at the same time, all simultaneously, whilst making sure that money goes to all of us at the same time. That's a really hard thing to do all at once, and that's...
At global scale, yeah. Airline ticketing and all that cool stuff. It does it. So it's not very pretty on the front end, because it does, once upon a time you fed in punch cards and it's got green screens, but it is that kind of workhorse.
And we're currently on the latest release is like a 17. A couple of years ago, they were looking at the throughput the kind of maximum throughput. And I think it worked out about 2 trillion transactions a day that it can run, which I think it's 1 trillion. 1 trillion or 2 trillion.
Yeah,
it's quite a big difference between the two.
Between friends.
But it was around the same number of Google transactions that run a year that can be run on a day. So it's quite a significant piece of kit, but obviously quite challenging to use at times and quite challenging to maintain. And that's why it kind of sits in the corner, the data center. We're trying to make that easier. That's our job. But
nobody puts the mainframe in the corner. Sorry, that was a nerdy, Dirty Dancing reference there. Yeah.
Well, and obviously, when we talk about finance, one of the big things here today is AI. So it can be used to look at things like fraud detection. So think of every transaction that's running in a Sainsbury's or a Tesco. All of that can also be run. I think it's simultaneous. Trying to think of the wording, when...
We're being recorded, so we can't bluff
I
this
know,
one,
yeah.
Louisa.
When the transaction hits the mainframe, it can also do the kind of recording at the back end in the database and also checking that the fraud detection has made sure that everything is good. So it can do both of those at the same time using
exactly, yeah. We will get into open source.
extensive large language models, which is very cool.
So the hardware boffins have been very, very busy making it super duper quick, doing all the world's credit card transactions. And what's interesting about it is that a lot of people want to score transactions, as Louisa said, so that you want to score the transaction using an AI model to say, well, is this really who they say they are? Is the retailer, the merchant, does this person have enough money? Are they out on a spending spree and they're just going to blow their limit and go somewhere that whatever reason, right? You need to have that, and lots of models do that. And having that co-located, so within the very latest models, there's it's called the Telum 2 Spry coprocessor, and basically it can do 450 billion inferences per day with a millisecond response time. So what that means is when you tap your card and it comes back and says, oh, you're not connected to your home mobile network, whatever, you're somewhere else, maybe you're in an airport, maybe you're in a geography that you weren't, and it's going to start challenging you, perhaps with two-factor authentication or something like that. That's what it really does. So you co-locate all of those. From a green energy point of view, because it's all co-located and it's running at quite a low temperature. If you ever go into a machine room, it's quite cold. It's like going into a sort of like going to the penguin enclosure. I don't know why I said penguin enclosure. Anyway, or the freezer department of Iceland or whatever. Anyway, so that's good. So a little bit of myth busting there. So the myth that we tried to bust was the fact that nobody uses them anymore. Mm-hmm. They're massively heavily used, and they're not just for legacy workloads as well. Those legacy workloads, which are banking transactions or buying an airline ticket, or so airlines as well, a lot of airlines as well, especially in the sort of current, I sound really sort of aged here, anyway, but airlines like to know who that passenger is, who bought the ticket, are they who they said they were, have we ever seen them before, are they going to get up to no good, are they a threat to the other passengers? So again, those are the airlines. Do you want to spend too much time on this slide, or?
Well, all this slide wanted to convey is that in AI and machine learning for Z, which is where you're doing all of that inferencing, we use a ton of open source models on the platform that can be moved on to, I think in this case, Z and LinuxOn to be used to do all that inferencing, and it's ported quite easily. So that was just, we do lots of cool stuff with open source in the AI space. It's available, and it's quite normal. So
cool, thank you. Myth 2, mainframes use proprietary operating systems. Sorry, you're smiling at the graphic there. I love it when I've got a room full of sort of, anyway, people. I love it. That's what Louisa said when she saw the graphic, she laughed. So once upon a time, they did use proprietary operating systems. They used weird systems called MVS and ZVM and blah, blah, blah. Okay, so.
They still use ZOS.
They still do, because you have to still run the old workload, right? That was written for it. But the Linux one, super, super quick box. But I'll just go to the next slide, unless you want to linger on this one.
No.
You sure? Mm-hmm. You sure that's not a passive-aggressive sort of look?
No, not at all.
Sure,
not at all.
Louisa? I don't want to. So, but we do run an operating system called LinuxOn Z. Okay, so LinuxOn Z is. This is from Wikipedia, and we can all trust Wikipedia. I just literally copy and pasted it like an hour ago from Wikipedia, because you wouldn't have trusted me if it came from somewhere else. There's lots of talks about AI and trusting the provenance of data, which is true. So you can run any Linux you want. Obviously, Red Hat is an IBM company, so obviously IBM will want you to run Red Hat Linux, and SUSE, Canonical, Debian, Fedora, a bunch of other stuff. There are more people, smarter people at this conference who know more about Linux than I do, the Linux OSs. But it just works. It just runs, right? You don't have to do anything that interesting. The OSs are ported and the OS providers are running it. So
yeah, one of the main things really about Linux and why the two boxes were created separately, even though they're really the same hardware underneath, is due to the sustainability of the boxes. So like we said, they can run a huge amount of transactions. They do that in a very clever way with the cooling and like all of the stuff with the data center, which is very clever. But there's a lot of work that's been done around taking x86 boxes and putting them into LinuxOn. They can run a huge amount of work. The challenge is that obviously it's got to be ported, the Linux operating system has to be ported onto the mainframe. So there are some quirks that come with that, quirks that products have to then support LinuxOn Z, which is a kind of a specific type of operating system. But it does run full Linux with all of those different bits underneath. But yeah, sustainability is one of the main reasons that LinuxOn is such a good box, because it can run a huge amount of workload on for a lot less footprint than a big data center.
Does anybody have a question or not? No, a little bit of pauses. Did anybody remember a television commercial, I'm just trying to work out the age, called The Heist that IBM ran years ago? I wish I'd got it anyway. It was a silly thing. Somebody was in New York and they went in and with a bunch of cops and they were like, somebody's stolen all the data. What did they steal? Payroll. And they go into this big room and it's all emptied. And they go to the back, and right at the very back of it, there's a IT guy going, oh, I just got rid of all of our server farm and I just got an IBM mainframe. Didn't you get the memo? It's quite a cool.
It's great.
Yeah, IBM is actually remaking it for the Super Bowl. So the interesting thing is, and I'm just can I geek out on TLS?
You can geek out as much as you want.
So
I'll
TLS,
keep you on time though.
TLS, Transport Layer Security. So a huge amount of the world's IT problems are simply created because one computer, one microservice A is talking to microservice B, and they're using TLS encryption in the middle, and they're using software to do that TLS encryption in the middle, and they're using certificates, and the certificates expire, or one of them is using an old cipher, the other one has said, oh, I need a newer cipher, and then they just can't handshake. I mean, it's a massive. Every time, if you ever go into a website and it just goes like 404, can't find whatever, that's very possibly why it can't do it. So within the IBM Z ecosystem is all of that stuff when those microservices are co-located and they're all running in containers. The software doesn't need to do any encryption whatsoever. So but when that's all co-located workload, what happens is you actually run with HTTP, which is quite scary for people, like, oh my goodness, I'm just running it like unencrypted. But what happens is the second it hits a network boundary, there's pervasive encryption. The encryption is done by the hardware, crypto cards. And they're all they've got quantum safe lattice algorithms and stuff. So it's super future-proofed, and it's also super fast, and it's also actually easier for the software engineers because they don't have to be futzing around all the time, sort of upgrading ciphers in weird properties files and things like that, and putting exclude lists and things like that. So a lot of companies go, wow, that was a lot cleaner. I just put on my software there. I focused on my software. It's a bit like open source and all that undifferentiated heavy lifting, which is just having a secure communication. The box just took care of it. And why shouldn't it? If you think about it, we all have custom graphics cards. We all have custom cards for different things on our machine. Why should we have to worry about that? Right? We don't say, if you're a games programmer, you don't literally say draw here, do this, do that, pixel by pixel. You just issue commands at a very high level, and the graphics card will take care of it and let you do really cool 3D gaming. Cool. Let's go on. Myth 3. Do you want to take this one, Louisa?
No. I think it's quite funny watching you go off on some tangents. I just like to chip in, make sure that I keep you on track.
Sure, thank you. So mainframes just run COBOL. Do people know what COBOL is? Looking, you do? A little bit of a grin, a little bit of a chuckle.
There is a disclosure here that I've been in mainframe about 3 years. I understand, I can look at COBOL and sort of get a gist of what happens, but I can't code COBOL. So you don't have to, I suppose the other myth on here is that you have to be able to code in COBOL in order to work on the mainframe, which also isn't true.
COBOL is actually really cool.
Because I can't, so.
Yeah, it's cool. It's a business language. And actually, I love from the whole kind of diversity point of view of computing, it was actually created by somebody, I think she's got Admiral Grace Hopper back in 1960s and stuff. There's a very kind of don't forget the incredible female pioneers who, and when they were programming the space program, Margaret Hamilton and people like that, they were literally started off just binding wires together, and then they basically created the high-level language that was COBOL for the business language. So it's phenomenal.
Well,
and it's still running.
And it was created, right, because of the... this is where I'll get it wrong. It's super good at being able to efficiently run through a huge amount of data and a huge amount at the same time.
And it crunches numbers.
Yeah.
A number is optimized on the hardware. Like for anybody who's used Java, right? Are there Java developers in the room, or like you are Java? Right, you have to declare, like, are you an integer? Are you a big decimal? Are you whatever? You have to declare your precision. If you get it wrong, it's going to overflow. You've got to do with primitive types and large types. And in fact, I think it wasn't written in Java, but Ariane 5 rocket crashed back in 1996. Ariane 5 rocket crashed because it was using Ariane 4 software, and it went up, and the telemetry was such that an 8-bit number was written, 16-bit number was written to an 8-bit register, and it was the world's largest software bug ever. So it's bad if your developers have to know about precision, and you go, oh, now I have to upgrade my modules to 8 to 16 to 32. But anyway, COBOL is like the storage of the numbers is just optimized, and they can just be like, they're perfect. There's no floating point. Every number is as perfect precision. Very, very clever. But people often think that COBOL developers are old.
Which is why I'm here with you, Joe, just to,
Little joke,
to balance us out.
So yes, it's true. I mean, and some people go like, what's the world's most popular programming language? It's almost definitely Python now, probably, versus Java, whatever, or maybe Rust, you know. I mean, those are the three that probably are getting the most traction at the friction surface of, you know, fingers on keyboards hitting, you know, git commit. But if you actually look at the vast volume of data, there is more stuff written in COBOL, you know, than there is in any other language, just because it's had a lot longer to do it. So it runs it, but there's also on the mainframe, every other language works, right? You don't have to be writing COBOL. So lots of companies are writing in Java, writing in Python, writing in Rust, you know, doing all that cool stuff, because that's where you know, they're just better languages, and for, you know, package managers and certain things like that. Obviously, if you need to get into sort of those kind of modules.
Well, a good example is when we talked about the machine learning. A lot of that's in Python. A lot of the libraries are in Python. A lot of the kind of native machine learning and AI tools are in that language, and so we have to adapt and change with that as well.
Yeah.
Very similar.
But as an interesting aside, well, let me go on to the next. No more questions.
Not yet.
Either we're doing well, or everybody's just gone on the feedback form. Like, these guys suck. Yeah, okay, let's go on a little bit. What have we got on this chart? Okay, a couple of interesting things, I would say, ironically, saved the mainframe, if that's a weird thing, or saved the amount of money spending on the mainframe. There's a wonderful line. People in this line, anybody watch Kung Fu Panda? You know, one often meets one's fate on the path one takes to avoid it, which is like, I think that Shifu says it, or maybe Uguay says it. You're looking at me anyway. Don't worry.
I have no idea.
Kung Fu Panda. Right, we're going to watch it tonight. It's a fine, wonderful film. So back in, did anybody here program in Y2K? Anybody Y2K? I'm looking around. I don't want to. It's all right, those you don't. Okay.
I mean, you know, I'm too young for that.
Yeah.
So you've immediately.
So Y2K. So the Y2K for folks who didn't do it. But you could tell me your story if you want. But like the basic fundamental. This is just how you define things in COBOL. People would literally. So I used to work for an insurance company like bazillion years ago, and I remember coding code in the 1990s where we had to program on an insurance policy, the inception date, the start date of the insurance policy, the expiry when it ends. Most people buy insurance for a year, for your car, for your house, whatever, or your boat, if you're lucky enough to own a boat. Well, that was a bit boatist of me. Anyway, well done for everybody who owns boats. So we would just have a 2-digit year, month, day, because you were worried about literally the size that the 4-character year would occupy. And I wrote all this code that would say, has the insurance policy expired? And you would basically go, well, is the expiry date, is today's date after the expiry date, you know? But the problem is, if the expiry date was 99, and then you went into 00, and the date was 00, all your maths just basically, I was going to say goes to something there, but I wouldn't say that because it's been recorded. But you see what's going to happen, right? You're now the 3rd of March in the year 2000, and 000303 is clearly before when your policy has started. So all your math goes horribly wrong. That was basically what Y2K was, wasn't it? Everybody had to fix.
It was a big thing.
It was a big thing.
Completely went away afterwards.
Completely went what, sorry?
Went away afterwards.
It went away afterwards, yeah.
Everyone
There's actually a
still talks
conspiracy
about it,
theory that nobody had to do anything, and we just all these consultants sat around and booked lots of money and didn't do anything. But as a result of this, lots of companies, when they got to sort of 1996, 1997, thought, oh my goodness, we're all going to die, right, quickly. And they fixed all their systems. So they actually modernized all of their systems. And there's a whole group of people who were then hired in to become COBOL developers or whatever the language was. And that actually gave a massive input of staff and universities. And they're called bug babies. So they actually, and there's a certain generation of people now, I think the demographic is just sort of 43 or older or something. It changes every year. And they sort of call themselves bug babies. And the COBOL 19s is the same thing happened again in 2020, 20 years after that, when COVID hit and basically everybody sort of scurried home and started working from home. And a lot of government systems, US government systems that had to pay checks to people, furloughed and do tax returns and change all the tax rules, were now had to be modernized. And a huge amount was done there. And interestingly, the Open Mainframe project, which we're going to talk about. So right now, COBOL, IBM gives free COBOL training to, I think it's like 50,000 people a year, 500 universities, just massive, massive. Within the UK, MMU, Manchester Metropolitan University, University of Bedford, University of Hertford, and things like that, which all didn't happen before this, because lots of employers were saying, help, quickly, we need to do more, work. So it's a bit like, I think, in the keynote, there was two things that motivate people. It's very much the fear and greed analogy. You're either frightened of something or you're greedy to do something else. COBOL was frightened of basically just dying over the millennium. All these systems couldn't work. They couldn't actually pay people, and things just not working through the pandemic. And the whole interaction model of these programs changed, which led to the line, our mainframe is cool again. So
I question the answer to that with the middle GIF. That's very
with what?
With the middle GIF.
The middle
very
GIF.
questionable, yeah.
But folks, I was actually watching a Doctor Who rerun the other night. Don't ask me why, because I'm a kind of a nerd and I like Doctor Who. And there was literally a line in Doctor Who where they're like, oh, I'm going to go to the galaxy's mainframe computer. And that's from The Matrix, right, which is all about the mainframes. And if you watch so many movies, everybody's like, oh, we're going to hack into the mainframe. Everything from Tom Cruise does it in Mission Impossible, I think. And it's like, you know, people break into their school records, let's hack the mainframe and things like that. So it's got that, a little bit of street cred maybe back. People don't quite know what it is, but they know it's something, you know, how big is it? Where it's in the corner, that it is. What was the bit you didn't like? What GIF did you not like? I think you approved these charts. Oh no, hackers in the mainframe. But it's interesting, and I pulled this off to the internet. I just literally Googled for the word mainframe t-shirt, and see, I'm just a proud legacy COBOL programmer, which is a kind of like self-deprecating one, because she's not, clearly, right? She's clearly sort of kind of Gen Z. But it does have that sort of panache about not just being those old black and white pictures, as being that kind of Hollywood line. No, there's actually a very good video on YouTube called Ode to a Mainframe. I won't play it now because if you guys have got nothing left to do, which is lots of Hollywood people running around going, well, they've hacked into the mainframe. The mainframe's run out of coolant, and so forth. Any questions about it? Anybody want to challenge me on that? No? No? Okay. How are we doing for time? We've got 5 more minutes.
I mean, we're kind of moving on to the why are we here? Because obviously we've talked about the fact it's proprietary. We've talked about the fact that we've got a LinuxOn, which is kind of interesting. It was ZOS is proprietary, right? Talked about COBOL and all the cool languages you can use, but actually there's a huge portion of development, of managing the systems, provisioning systems that can all be used via open source. So these are just some of the examples that I work with day to day in my teams that are open source projects, open source initiatives that are all available through the mainframe. So give some examples. For example, we've got a VS Code logo there, where you can use VS Code through Zowe, which is also on there, which you can modify data sets, you can write COBOL code, you can write...
you can touch all of the old code all the way back to 1964 through all of today's code and tomorrow's code. It just works, and you can debug workload running across language boundaries and things like that. It just all works.
You can use Ansible to provision and use as configuration as code. So there's a huge amount of Ansible collections for things like Kix, which is it's like the banking application that runs alongside things like IMS and DB2, which are big subsystems that are used on the mainframe. Ansible can help you bring those up, provision them, manage them. Really, really clever. Same with Terraform, which is kind of recent in the last year. IBM acquired them, but we've been working with Terraform for a while, looking at how we can bring up the actual infrastructure on the box. So that's really cool, really exciting with Terraform. You can edit the code. A lot of guys still and shops still use the older proprietary ways of developing the source code, but you can, and people absolutely do use GitHub. So all of the stuff that we've been talking about today, Git proxy, all of that is still absolutely useful for a mainframe developer. All can be used. And then as we go further, I don't know, in this chart I sort of had the idea of, well, as we go further along the pipeline, so you've got Jenkins and Tecton there, all CI/CD pipelines that you can run, dev, test, validation, all of that stuff. My project, Galasa, is all about testing, so automated testing on the mainframe is absolutely something you can do through Java. Java implementations doesn't require huge amounts of in-depth knowledge of the code base in order to test the applications. So we'll talk a bit about that in a second. But there are a huge amount of projects that you might not think, oh, well, you can just use CI/CD pipelines, but you can absolutely do that.
You can, and if you're on one of these projects, if you can get a supported version of your software, which you can port, it's not that hard to port it. Supported version, you'd be surprised by how many people will come and go, ooh, if you give me a service level agreement, SLA 24/7, here's lots of money to make sure that if you put it in a banking production system, you've got a happy customer.
Well, and one more thing, there's a use of Kafka here. So Kafka is obviously massive in the distributed world, used all the time, and something that we use a lot at the moment. It's growing. Event-driven architecture over the last couple of years has grown massively. And uses for things like notifications. When you've paid for something, notification comes on your phone. It's probably Kafka. So there's a huge, from my perspective, it's only this list will get here next year, and there'll be a huge amount of other open source projects that it means that people like me at 3 years into mainframe, I've been in other parts of IT, but I can use all of these without needing to understand how the data sets work on the machine. I can rely on Joe. Joe can do that bit. I'll do the interesting bit on VS Code.
Did you just call me a COBOL boomer? I think
maybe.
Okay.
Maybe.
And under the Linux Foundation, both Louisa and I are part of something called the Open Mainframe Project, which is a kind of coalescence. It's an umbrella foundation,
It's a
bit like
project.
a CNCF. So lots of different projects to do with open
Sister project of FINOS.
Yeah, so we're very much, and we're both Open Mainframe Project ambassadors. I think we're almost running out of time now, so we're just going to wrap up.
Right, we've got about
You've got a question, Liz? Yeah.
If you were running Linux on a mainframe, are you running it in like a virtual machine? I'm guessing it's not like Linux with 58,000 cores and 200 bazillion gigabytes.
So the question was, if you're running Linux is it a Linux virtual machine? Yes, everything's virtualized. Yeah, so it's heavily virtualized. Yeah, so everything is virtualized. Yeah. Was that the answer to the question that you wanted? Yeah, and that's a good thing.
That's fine. Yeah, I was just imagining like a sort of massive instance of Linux that can use all of the resources.
Oh, so your worry was, could you use all of the resources available? Could you use all of the sort of 40 terabytes of storage and everything like that? I think 40 billion transistors are on a single chipset. If you configured it that way, you could. But sometimes when I go to visit banks and I go to visit their mainframe system programmer, you've got Gandalf, right? You've got somebody there who basically thou shalt not pass. No, there's lots of checks and balances, and actually security is built into the OS as well, so you never have to make checks. So there's every single call goes through what's called SAF, which is Security Application for. You had a question quickly, yeah?
Yeah, so I come from high performance. I'm working with high performance systems where we have our applications pinned to the core.
Cool.
Why are we using not IBM Z kind of things?
So that's a good question. So your question was about HPC, high performance computing. So I don't want to give an IBM because it's an open source. So this is a highly optimized machine used by banking and finance, what we call systems of record. It keeps your data You know, your social security number if you're in America, your driver's license number, you know, who's got that airline ticket, you know, your bank balance. And it's at the core, and there's lots of stuff buzzing around it, people doing mobile payments and running through and tapping, things like that. And it just makes sure that all of that's safe and secure. So there's also high-performance computing for doing, like, I don't know, modeling amino acids, modeling, like, you know, whatever, anti-vaccines and things like that. This is not the box for that. IBM could sell you a box for that. It's called the IBM Power box, but yeah, but which also runs Linux as well. But because this is FINOS and it's a finance and open source, this is where we're headed for that. Does that make sense? Yeah. Yeah.
Just because you said that it's got a higher throughput and everything, it sounded like it could be optimal for.
It could be, and interestingly, the world record for Minecraft. Folks know what Minecraft game is? Yeah? The world record for the fastest ever Minecraft is held by this machine. Because there was somebody who entered a hackathon, and he knew that when he got, and he basically just ported Minecraft to it and just said go, and it just went, and it just like literally, it's like we're talking to 3 or 4 zeros after what the previous world record was. And then he managed to get a trip to San Francisco paid for by IBM, because it was quite cool to have this like kind of like, you know, got up on stage, kind of like, you know, and looking at you with red hair. I think you did have red hair, Liz. And it was super cool, because it was just complete, everybody was like, you're running Minecraft. So yeah, obviously, if you want to, you can run a Java gaming server, which is what Minecraft is. And it's just literally going to smoke the records. You know, you hit, you know. Sometimes I do stuff, and I go, how long did it take? And it just goes 0.0000 milliseconds. And I'm like, but I know you burnt some CPU, but it's so fast, it can't even record it on the engine. Yeah. But it's an interesting angle. As could there be some HPC? Interesting, good question. We'll have to take that away and noodle it. But we're mostly in the financial services business. Yeah.
Any other questions?
I know we wrap up to the next speaker. So, it's not your grandparents' guru. I think we've covered most of it. Nobody uses the mainframe. So I'm just going to let you sit through. I spent quite a lot of time doing this animation. It's okay, but yeah, if you've got anything more you want to do, let's hang out and talk. The most important thing, one of the reasons we came here as well, is that if you work for a bank, if you work financial, and you're doing lots of open source on the kind of edge and the periphery and the sort of GUI space or the AI modeling space, don't forget don't forget your mainframe workloads, right? You can bridge, you know, you can get really close to that. You can port lots of stuff there. If you're a vendor, and you want to start, it's always good to start selling. People often say, like, give your software away, you know, sell it to banks and sell it to government agencies, because government agencies pay more than banks, right? And they're more slower to get rid of it. Well, nothing against government agencies procuring software. But it's a very lucrative market to be in, right? These financial institutions, they're rich, and they will pay well for you to port your software there, but also provide it reliably. They don't want you just rocking up and then like scooting out of town when the sun sets. Liz, you have a question?
So you got me thinking there about, well, you know, we hear a lot about banks running in the cloud, running multi-cloud, but they've also got these mainframes. Is anybody doing like a sort of hybrid cloud where they're working?
Oh, that's an excellent question, yeah. So your question was about hybrid cloud. So your question was, you hear a lot about cloud. Obviously, yeah. This thing doesn't have a presentation layer. This doesn't have a graphics card, right? Basically, your workload comes in probably through a REST API, or there are other, you know, .NET. Yeah, so, but it's a transaction server, so it's your system of record. But then you're going to have probably some blades in front of it and then some presentation layer and stuff will be. So yes, the answer is yes. Everybody who uses this uses it as that kind of last. And then often workload will come into here that will then just pop out to do some fraud detection, to some fraud detection service that will pop back in. So it's not a kind of end of the road buffer. It's very much, you know, it gets workload flowing in and out of it. It does. So it's a good question. I think you knew that already. Was there a question behind the question, or?
No, I was it just occurred to me that, well, as I say, we talk a lot about hybrid cloud, about workloads moving from one cloud to another cloud, but maybe your mainframe can also be, if you're in possession of a mainframe, your mainframe can be part of that.
Yeah, and these do actually.
I don't know.
Yeah, absolutely.
Yeah.
You find in most customers that we work with, they have both as a strategy. So as Joe said, Yeah, it's fine.
Yeah, no.
There are examples where so if they were doing bank settlements, the data will come out of Z, and it will get ported into a high kind of what's the word? Highly tuned out like mathematical models and algorithms that sit outside, because that's easier to do, easier to manage, and then the data comes back, and they do all of that kind of seamlessly back and forth. So it is really common, but it's just not talked about.
Yeah.
Yeah, thanks for coming.
Thank you for coming.
We have to really, there's a speaker code of conduct, and I just want to really respect the timing. Thank you very much for
Okay.
coming.
Thank you
and
so
we're going
much.
to be at the door if you want to find out more. Thank you. Thanks for moderating the session.
Thank you.
Thanks, Louisa.